This is another engineer video. I figured I should do this quick because I just did the video on using a raft to create a bridge essentially for equipment or casualties to move across a body of water, across a river. I figured I should talk a little bit on doing ferry operations. Now, my understanding on this, and it may not be correct because I'm not a bridger, a raft is unpowered. A ferry has some means of locomotion on it, some means to power it to get it across the water. And it's just going from one shore to the other, back and forth, back and forth. Now, before they created boat motors, they still moved ferries across rivers and streams to move stuff from one bank to the other. So I'm kind of going off of, what little I know from history on this, which granted is not much. Okay, so we're going to have our body of water here. This is upstream, that's downstream, so the current's pushing this direction. Now we're going to have our raft, or ferry at this point, because you're going to have a person or two, or however many are needed, will be on here to move supplies going across. Attached to this is going to be either one rope or two. How many ropes should you have on there? It really depends on how strong the current is in this river. The stronger the current, you're probably going to want two ropes connected to each side. If it's not that fast moving, you can probably get away with just having the rope on the one side. The side that that rope should be on is upstream. The river's going to be pushing across. Not an expert on this, told you that. This rope is going to be anchored on each shore. We'll come across the top of our ferry over the top of the guardrails on either side or on one side, and it's going to run through loops or hooks which are connected to the guardrail on that side. Your ferryman will stand on either end pulling your ferry across the water, whichever direction he's going. If they're going to this shore, he's going to be on this side pulling the rope, moving the ferry across. If he's going to this shore, he's going to be on this end pulling, going across. If you got two ropes, well, you're going to have one on each side pulling your way across. Potentially more people, especially if it's a harder current. The shores on both ends are going to be relatively easy, that whatever is on top of the ferry here can just roll right back up onto shore easily. So it'll be about the same height. Maybe you're going to grade it at kind of an angle. So you get off the ferry, you go up a small slope. Another option is, I've seen this done in movies, where they'll have a gangplank on either end. You get to the shore or close to it, they spread that gangplank from the ferry to the shore, those last few feet, so people can walk across, or they can pull wagons across, or the horse can go across, whatever. Now, how could something like this get set up? And this is what I could come up with. Now, first, the raft itself, you got your decking here underneath. You're going to have at least two pontoons, potentially, depending on the size of the ferry that you're doing, you may want 3 or 4. Most likely in this situation, if it's old school, figure it's going to be large logs, stripped of any branches or anything on the sides, any nubs that could cause resistance in the water. And then you're going to have these rounded off or angled off so that as you come up on the shore, you can ride up onto it. You have your decking attached to the decking, potentially from decking and right to the pontoon itself on that side. You'll have your guardrails hammered in. Then you're going to have, at probably a 45-degree angle, definitely right below where the rope is going to attach, you're going to have a support, which will also be anchored to the decking. It's going to get nailed onto it or screwed onto it. Potentially you're going to have a piece of wood going the entire length of the ferry that this support butts up against, so that it puts the pressure on that piece. So let's figure, say, 2x4, 2x6, or 4x4, something like that, for this support to butt up against. This is help give support here on the side from the pressure that's being exerted on it from the water coming this way, and you also got the rope sliding across the top. It would be the same over on this side if you're doing double rope. If you're only doing single rope, you're definitely going to have it on the one side, and then your other side you're going to have probably just the guardrail. Wouldn't have to worry as much about the supports. How often should you put the supports onto that ferry? It depends on the length. I'm going to say probably a good guess is probably 4 to 6 feet. Every 4 to 6 feet of length of that ferry, you're going to have one of those support braces on there, supporting that guardrail, which is going to go across. Now over here, I have kind of the anchoring system, which would be on the shore. So we're going to need that rope to stay at a constant height so that it can feed easily through our eyelets, our clevises, whatever, on top of the rails here or on the inside of the rails. So we're going to have our rope that's going to stretch across. We're going to have some type of support or column here, which you're probably going to U-notch it a little bit on the top, so maybe a good chunk of log here. Rope will come through that U-notch and then angle downward to an anchor, which will be driven in at an angle. This point here will be closest to the water. This point would be away. So the water's over here. It's going to be driven in like that so that it gets a better hold on it. It's going to be a lot harder to pull that anchor out. Now, ferry operations, from my understanding from history, they essentially worked year-round as long as the water was open, because once water froze over, didn't need to use the ferry, so maybe you beached it at that point. You know, whatever procedure you had in order to protect it from getting banged up by the ice. So this is not usually something that would be done as a temporary thing. This would be something for longer term use. You're going to use it over and over and over and over, because it's going to take a lot more man hours putting it together, getting it all set up. The depth of the water underneath your ferry, you're going to figure it's going to have to be a few feet, because the ferry will sink down the heavier load you put on it. Could you transport a vehicle across on a setup like this? You potentially could, depending on the size of your raft and its load capacity. How do you increase the load capacity? Add additional pontoons on the bottom, or make them a little bit larger diameter. You know, your little 6-inch diameter is probably not going to do it if you're going to try taking a vehicle across. I would be thinking 18 inches, maybe more, depending on the size of your vehicle or the weight of the load. When you get that ferry or that raft loaded down to the point where the decking is getting close to the water line, you've definitely gone the max you want to go. I would probably give yourself at least 6 to 8 inches between the top of your decking and the top of the water, because you're going to have waves that are going to get pushed up over the top because of the current hitting the side of the pontoon, and then the water's going to want to keep pushing going over the top. So you want some separation. You don't want the material on top getting wet, especially if it's casualty you're bringing across. You know, that casualty's in a miserable shape as is. If you're trying to bring supplies across, you know, moisture is not necessarily a good thing to add to a case of rations or bags of rice or whatever you're trying to take across. So here you go. It's a potential way of doing a ferrying operation, old school style. Now, for all my engineer brothers in the Patriot and Militia movements, always remember, essayons.